Next problem's up. Let's check this answer. It's supposed to look like that. Most of you guys left the minus in the top all the way through. I just factored it out. Okay. Say that again. Anybody want to see that one worked out? Yeah? Okay. On the xy, I have to see that as a product, x times y. So when I do the derivative, I've got to think product rule. The derivative of x is just 1, so the second part is just going to be y. Plus 2 plus 6x equals, the derivative of a constant is just 0. Okay? On tomorrow's exam, A, B, C, and D, those first 4 letters of the alphabet, those are constants. On the whole exam, A, B, C, and D are constants. Okay? So I can see pretty quick that I'm going to be subtracting all this stuff to the other side. I get x, y prime equals negative 6x minus y minus 2. And then I divide by the x. Y prime equals negative 6x minus y minus 2 all over x. If I take out the negative sign, like they did, I get their answer. Just factor a negative 1 to the front. Does that work for you guys? Okay. Got one more for you to try here. Which x? The derivative of 2x is 2. That. The derivative of 3x squared is 6x. Yeah. The y, these first two terms came from the product rule from that term. Okay. There's the last one that I have pre-planned for you guys today. We're going to work on that for a minute or two. This is a form of the answer that they'd like us to get right here. That's a form of the answer they'd like us to get. As the guys in the back said, we could factor out an x to the 4th and a sine x. We don't necessarily have to. You guys want to see this one? I'm going to rewrite this just a little bit because it's the way I think of it when I do it anyway.
That would be a lot easier to see.
Right? That's what it means. When you have sine squared, it means sine of x. It means that function squared, right? So if I'm going to do this, I have to do a product rule. So when I follow the product rule, I keep my first function, multiply by the derivative of the second function. Well, the derivative of something squared says I got to bring down the 2. I keep what's inside, and I reduce that power by 1, right?
Yeah.
Then I have to follow the chain. I have to multiply by that derivative of the function that's inside, which is going to be cosine, right? That's the first half of the product rule. Plus, next time I'm going to keep this sine squared this time. I'm going to go ahead and write it this way again. And then I'm going to multiply by the derivative of the x to the 5th, which is going to be 5x to the 4th. And then it's just a matter of putting it in some form that I'm happy with. So we've got 2x to the 5th, sine x, cosine x, plus 5x to the 4th, sine squared x. That makes sense? Okay. So, yeah.
Okay, this has nothing to do with the problem itself, but if you have an equation that has sine x squared instead of sine squared x, would the derivative of that be cosine x squared times 2x?
That's a great question. Let's follow that up. So we're going to clear this off right here. And we're going to create a new function. So you're saying like this, right?
Yeah.
And you're saying what would be the derivative of that?
Yeah.
Okay? Do you guys care? This looks like a chain rule to me because I have a function inside a function. I have composite functions. So I'm going to take the derivative of the outside function first. Which one's the outside function this time? The sine. So that's going to be cosine of x squared. And then I need to multiply by the derivative of the inside function, which would be, the derivative of that would be 2x. So it looks like we're going to end up at 2x cosine of x squared. Now, do you want to verify that real quick? Just to make sure? I want to verify it real quick. So let's do the derivative of sine of x squared, right? Let's see if it understands what we typed. Were we asking it to do the derivative of sine of x squared? They got 2x cosine x squared. That's what we got. Plus a whole bunch more information that we're not really looking for at the moment. It's not going to redraw that for me. Any other questions? No more questions. That's all I have pre-planned for you guys.